Hello, my name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for TEAS. We have been solving TEAS math problems out of this book here, the official study guide, official study manual for TEAS 2021. If you do not own this book already, purchase one immediately. You're going to need it. Today we'll solve some problems. There are 5 of them that you will find on page number 179. 5 problems dealing with inequalities. 179. Let's turn to it. Page 179. Number 1 says that we're going to start out with 9 cards. It's always important that you have the book in front of you. Whenever you're working with me, you must have the book with you, because I do not write down the entire problem. I just give you the gist of it. So we're still going to start out with 9 problems. Then he goes on to say that we're going to add 2 more each week. Each week we're going to add 2 more to our collection. The question simply is how many weeks before we have more than 35 cards. It doesn't say how many weeks before we have 35 cards. That would have been an equality, that would have been an equation. Here we're dealing with how many weeks before we have more than 35 cards. That's what makes it an inequality. So let's begin then. So we're going to start out with 9 cards. That's our beginning. We have the 9 cards already. And then every week we add 2 cards to it. We're going to add 2 cards, 2 times W. W represents the number of weeks that's going to take before we end up having more than 35 cards. For example, at the end of first week, W equals 1. It's going to be 2 times 1. At the end of second week, it's 2 times 2 plus 9, and so on and so forth. And this quantity, it says how many weeks before we have more than 35 cards. This quantity, how many weeks to have to go by before this quantity is more than 35. Oh, it doesn't say more than or equal to. It simply says more than 35. So equality is wrong. It does not say more than or equal to. It just says more than. That's what it is. Now we just have to solve for W. Now as far as the book is concerned, as far as this page is concerned, they're simply asking us to set up the inequality. And as long as we set up the inequality, we're done. The problem is done. That's the answer. We're going to solve it anyway. It's very straightforward. This is a positive 9. Let's get rid of it by subtracting 9 from both sides. The 9 is going to drop out, and 2W is greater than 35 minus 9. 35 minus 10 would have been 25, so it's going to be 26. Divide both sides by 2, and we find that W needs to be more than 13. W needs to be more than 13. If we have only added our 2 cards each week for 13 weeks, in 13 weeks time, we would have only had 26 cards. We started out by 9, so that's going to give us 35 cards, and therefore W has to be more than 13, because at the end of 13th week we only have 35 cards, because 13 times 2 is 26, plus the 9 that we started out with. There's 35 cards. We need to have more than 35. We need to go one more week. The number of weeks we have to keep adding our cards to our collection is more than 13. In other words, at least 14. That was number 1. Let's move on to number 2. There are 5 of them, as I said, on the page, as you can see clearly. We're going to go through all of them. Number 2 says that we're going to save $25,000, or $25 rather, per week. We're going to save $20 per week, or saves rather, this person, and we are told that this person got $15 from his brother. Question is, how many weeks how many weeks does he need to save? Does he need to save to come up with at least $255. $255. So this person, the question goes on to say that this person wants to buy something. James is saving money. Oh, he wants to buy. He wants to save because he wants to go to a concert, and it turns out that the ticket of the concert is $255. Therefore, he must save at least $255 because he wants to go to concert so badly, and his brother was nice enough to give him $20 to start out his process, and after that, or rather, $15 from his brother, and after that, he started saving $20 per week. Again, this at least part is what makes it an inequality. So let's do that. Same exact process as before. So what do we have? What are we starting out with? Well, in this case here, we're starting out with $15. He got $15 from his brother. After that, he saves $20 every week. So it's 20 times W. At the end of the 5th week, he will have 5 times 20, which is 100, plus the $15 that he has from brother. $115, he still has ways to go. 5 weeks is not going to be anywhere close to enough. So let's find out how many weeks this guy has to save, except, and this amount that we are trying to save here, this total amount, 15 plus 20 times W, has to be at least. So here it has to be greater than or equal to. Here we need the equality sign here, greater than or equal to. It doesn't say how many weeks does he have to save to come up, it's more than 255. It says at least 255. So 255 will suffice. 255 will suffice, would be enough, more than enough. That's all it needs. Not more than enough, but it should be enough. So that's it. Same exact thing. Let's subtract 15 from both sides. This part that we're doing again is not necessary. The book is not asking for it. The question is not asking for it. The question is only asking us to set up the inequality. We have done so here. That's the inequality we're dealing with. This is just extra. So 15 is going to go away. That becomes 0, this becomes 4, this becomes 2, this has to be greater or equal to, very good. 20W has to be greater or equal to this. Let's divide both sides by 10, so 2 is going to drop out. Let's divide both sides by 2, and we end up with 12. There you go. W has to be greater than or equal to 12. What do you know? W has to be greater than or equal to 12. So what happens now if he saves for exactly 12 weeks? Well, if he saves exactly 12 weeks, each week we know he saves $20. 12 times 10 is 120, 12 times 20 is 240, so he will have saved $240 plus the $15 that he got from his brother, hence giving him at least $255 that he needed to go to concert, that he needed to be able to go to concert. Number 3. Number 3 says that this person has $25 for a cab ride plus the tip plus some change for tip. That's their way of saying don't worry about the tip. We are further told that the taxi that he's going to take charges $2 to get in, just to get in. And then after that it charges plus $1.75 per mile. The question simply is, how do we set up an inequality that shows the number of miles he can travel in this taxi before he runs out of money? Well, so again, quite straightforward, same process as before. As soon as you get in the cab, you have to pay $2. That's the minimum charge. After that, it is $1.75 per mile, so we're going to use M for mile, $1.75 per mile, and this amount that we don't need a dollar sign here because there is no dollar sign here. We don't usually put the unit sign in the equation itself. So this is $2 that we have to pay initially as we get in, $1.75 times the number of miles that we're going to travel, and this amount cannot be greater than $25 because $25 is all he has. But we do not typically write it like this. We don't write like this by saying it cannot be greater than this amount. What we have to write here is that this amount that he has to pay has to be either less than or equal to, which is same as saying it cannot be greater than 25. It can be equal to 25 because he has $25, and that's it. That's the inequality that they're looking for. Let's go to number 4. In number 4, we are told that we're going to drive. We're going to drive someplace. Number 4. We are told that this person has already driven 100 miles of his journey. Then he goes on to drive. Then he drives at 60 miles per hour for the rest of his journey. We are told that he must drive at least 350 miles. Again, at least, that tells us that one more time we're dealing with inequality. Of course, we're dealing with inequality. That's just the whole bloody point of this whole page. All 5 of the bloody problems are dealing with inequalities. So he must drive at least. That's the inequality part. The question is, how many hours? How many hours will it take him to finish his journey? A journey where he has to travel at least 350 miles. We are told that he has already driven 100 miles of those 350 miles, which means he got another 250 to go, and he's going to continue driving at 60 miles an hour from that point on. So he has already driven 100 miles already. After that, he drives 60 miles per hour every hour. 60 miles per hour every hour is redundant. We don't want to do that. That's too much driving. He's going to drive at 60 miles every hour or 60 miles per hour, which means at the end of 1 hour, he will have traveled 60 plus 100 miles. At the end of 2 hours, he will have traveled 120 plus 100, that's 220. He has to go at least 350. So this number of miles that he's driving has to be at least, which means it has to be has to be greater than or equal to. It has to be greater than or equal to. If he ends up driving 360 or 351, that's not a big deal. He has to drive at least 350. That tells us they're looking for greater than or equal to. That's it, same exact thing. If you wanted to solve this thing, you could do that. Again, the book is not asking for it, but there is nothing to it. We subtract 100 from both sides. We'll end up with 60 times h has to be greater than or equal to 250. Divide both sides by 10. And now 6h equals to 25, which means h has to equal to greater than or equal to 25 over 6, which is same as 24 over 6 plus 1 over 6. 24 over 6 is just 4, so it's 4 and 1/6 hour. 4 and 1/6 hour. What is a sixth of an hour? Hour has 60 minutes, therefore sixth of an hour is 4 hours and 10 minutes. Now we understand what we have done here. We have done a lot more work than was called for. All we were asked to do is to simply come up with this inequality. That's all the problem requires. That is all the problem was asking for. Let's do the very last one, number 5. Number 5, the very last one on the page. Number 5 says 3 more than 5 times x is greater than, again the inequality part, is greater than 3 times the same number decreased by 9. What the hell does it mean? It's a mumbo jumbo. We're going to have to read it again. No need to freak out. No need to get all worked up. No need to get your knicker in a twist. Let's just read one more time. Take a deep breath. Let's read one more time and see what happens. 3 more than 5 times x. Well, that's the starting point. 5 times x. 5 times x. And then 3 more than that, which means we have to add 3 to it. This is 5 times x, and 3 more than that, that's amount. Is greater than, there you go, is greater than what? 3 times the same number, which is x, decreased by 9. That's their way of saying minus 9. There you go. That's all there is. And again, if we wanted to solve this inequality for x, we could do that. The question is not asking for it. We're just going to do it anyway. It only takes a second, just for the hell of it, just for the fun of it. After all, you are here for fun, aren't you? Let's do that, shall we? Bring the x's to this side, numbers to that side. So I see positive 3 here. Let's bring the positive 3 to the other side by subtracting 3 from both sides. So that takes care of the 3. Let's bring 3x to this side. This is a positive 3x, so let's subtract 3x from both sides. And that's the positive 3x. There you go. Positive 5x and a negative 3x is positive 5, and a negative 3 is going to give us positive 2x. And that has to be greater than or equal to, that goes away. That was the whole birdie point. And negative 9 and negative 3 is going to give us negative 12. Divide both sides by 2, which means the x needs to be greater than 6. X needs to be greater than 6. As long as x is greater than 6, then this inequality would work. As long as x is greater than 6, this inequality would work. Tell you what, I'm going to show you a couple of examples so that you understand what I mean by that. 5x plus 3 is greater than 3x minus 9. Let's do it here. 5x plus 3 is greater than 3x minus 9. X has to be greater than 6. Let's try on this side. We're going to try x equals to negative 5. Would x equal to negative 5, would it work here? The answer is no. Answer is it's not going to work here, because negative 5 is not greater than negative. Oh, negative 5 is greater than. What the hell am I talking about? Negative 5 is greater than negative 6. So yeah, that would work. If you were to put in negative 5 here, you will see that this inequality holds. Let's put it very quickly. X is negative 5. So it's 5 times negative 5 plus 3. 5 times negative 5 is negative 25 plus 3 is going to give us negative 22. Let's see what we get on this side. 3 times negative 5 minus 9. 3 times negative 5 is negative 15. Minus 9 is negative 24. There you go. You see, negative 22 is indeed greater than negative 24. It works. On the other hand, had we put in x equal to, let's put in x equal to negative 7, that would not work, because negative 7, it says x has to be greater than negative 6. Negative 7, if you were to put in negative 7 for x here, it would not work, because negative 7 is not greater than negative 6. That would not work here. I'll show it to you very quickly. Let's put in negative 7 here. 5 times negative 7 plus 3. Negative 7 and a 5 is negative 35 plus 3. And that's going to give us negative 32. And on this side we get 3 times negative 7 minus 9. 3 times negative 7 is negative 21. Minus 9 is going to give us negative 30. And as you can clearly see, negative 32 is not greater than negative 30. Negative 32 is actually less than negative 30. So any number, as long as that number for the x, as long as that number is more than -6, this inequality will hold. We put in -5, it worked because -5 is greater than -6. We put in -7, which is not greater than -6, therefore it does not work. We're going to stop right here. That's the end of the page. We're going to stop right here. Tomorrow when we meet, we're going to go on to our next chapter, chapter number 30, which deals with graph. In the meantime, if you wish to get hold of me, if you would like to work with me, if you would like to hire me as your tutor to get you ready for the exam, you can get hold of me by sending me an email. Just go to keshwaniprep.com, send me an email, and we'll talk some more. Alright? In the meantime, if you want some more preparation for yourself for the TEAS, on my channel you will find a series of 80 more videos that deal with TEAS, an older version of TEAS. But as I said yesterday, math is math. Math does not change. There are 80 videos. Just search for TEAS 5. Just search for TEAS 5 day 1 and you will find it. I'll see you tomorrow, okay? Bye now.